We are going to learn about linked list. So what is linked list? This is a picture to represent a linked list. Link means 연결. There's a kind of connection between each of the node. First, we want to see about singly linked list. Singly means single, okay, one. And when we deal with the singly linked list, by the definition, it is a concrete data structure consisting of a sequence of nodes. So we have nodes and there is a sequence. And the sequence, it will be from the head. We call it head. So it is a collection of nodes that collectively form a linear sequence. This is one node. This is another node. This is another node. This is another node. So I can say this is node 1, node 2, node 3, node 4. Every node or each node stores element. Okay, so let's say this is the node. So in the node, we have a data, which is the element. And we want to know what is the next node. So there is a link to the next node. So if you see this one, this is a node. And this node has an element A. And this node, a link, there is a link to the node B. And node B, there is a link to node C. Node C has a link to node D. And then we have the head. Head means this is the first or the front. And then we have empty. Empty means the last node. One of the application is about the routing sequence. So if we have a routing, we have node 1, node 2, node 3, node 4. If you look at this one, what is the difference with queue? Queue versus linked list. What is the difference? In this case, we want to see the relationship between one node and the other node. So there is a connection between one node and the other node. There is a connection between one node and the other node. So this kind of operation usually happens in the word processor or maybe like notepad. You have delete and then undo operation. So let's say I'm going to delete this one and then I'm deleting this part. I'm deleting this part because I already deleted this part, this part, this part. There is a kind of procedure to undo. So I can return back to here, undo, I can return back to here. So this kind of operation, we can use the singly linked list. Or the photo viewer. The photo viewer, it will follow the sequence. So after you see one picture, you can go to the next picture, you can go to the next picture, you can go to the next picture. Okay. This kind of data structure can be used as the auxiliary data structure for the algorithm. You can use it for the list, for stack, for queues, also for array. And it can be used for the other data structure. This is the Python code. So this is the overall of the node. Yeah, we will take a look later, more detail. We will have the node as the class name, and there should be an object, and there should be at least one node to represent what will be the next. First, the node will be empty. And then after we create the node, there should be an object, and then we want to know what is the next node. So we have two things. The first is the element. What is the element? Maybe we can say the node is the element A or B or C or D. And then the element A is connected to element B. So the next of A is B. The next of B is C. The next of C is D, and so on. The other method is only to access. So we call it the accessor method. We want to get the element. We want to get the next. We want to set the element, and we want to set the next. Actually, this code is in Java. Okay, this is not in the Python, but at least you can see the structure. It is similar with Python structure. When we do with the linked list, there are some operations. Okay. Every data structure, you will handle at least two kind of operations. The first is insert. Okay. How to insert a new element, how to insert a new data, how to insert a new node in this case. And the other operation is delete. Based on these two operations, yeah, we can check whether the data structure will give you the most optimum or the most efficient operation or not. If the operation is O1, then of course this is very good. If the operation is O1, yeah, this is very good data structure. Now let's see. In the case of the linked list, I'm going to insert at the head. So in head means the front or the first data. If I want to add in the head, so I will allocate a node. So let's say this is the new node. Insert new element. Okay, so we have the element. Let's say the element now is the city name: Rome, Seattle, and Toronto. Okay, based on this sequence, it seems that this is a kind of travel plan. Someone wants to travel from Rome, and then he or she will go to Seattle, and then he or she will go to Toronto. And then after this will have a new plan. Yeah, the person have a new plan. He wants to add a city, Baltimore. And he wants to visit Baltimore first. So he or she wants to insert a new element at the front. When they know that the front is Rome, so the position here head will be moved to the new node. In this case, the head now will be in the new node, which is Baltimore. So we can have the update section or the update function to shift the head from the previous node into the new node. Remove. So remove means delete. We want to update the head to the point to the next node in the list. So why there? Wait a moment. There seems to be. It seems duplicated. Okay. Let me check with your materials later. So here we have the head, and then I want to update head to point to the next node in the list. So let's say I'm going to remove the Baltimore. So I do not want to go to Baltimore. And then instead of going to Baltimore at the first, I'm going to Rome for the first time. So this case, yeah, it is easy. Just try to remove this one and then move the head into the next node, because we have the connection about the next link. We have the connection, the next link will be this node. So this allow garbage collector to reclaim the former first node. Because I know that this is the former first node, it returns back to this node for the new head. Now, the other issue is when we have a tail. Oh, why? This one. I just double. Now, when we have a tail means the node that is at the end of the linked list. Let's say I'm going to allocate a new node. So after I have the Rome, Seattle, and Toronto, let's now put another node, which is Zurich. After I allocate a new node, now let's insert a new element. So I'm going to insert at the end of this node, have a new node point to null. So I need to put this symbol. This symbol means null. Null means nothing. So because this is the last, or because this is the tail, the connection or the link will be to empty. So empty node. After you have the node point to null, we want to have the old last node point, in this case Toronto. The original link is to null. Now I want to update this null into the new node. So it means this node or this next node will be updated into the new node. So update the tail to point to the new node. Update the point, this one, into the new node, which is Zurich. Then we have a new tail, which is Zurich. Now the issue is when we want to remove the tail. Oh, this is the same. So when we want to remove the tail of a single linked list, it is not efficient. Not efficient means whenever we do the data structure, we always try to find whether the insert function or the delete function has the O1 or not. If the big O is 1, then we call this is constant. If we have O1, or this is the most efficient operation, then that data structure is very good. So we can use that data structure to any problem that we want to solve. So for example, yeah, in the inventory, if you want to solve the inventory problem, yeah, you can use stack. and Q, because those two data structure, we already learned that the insert and the delete has O1. But for the linked list, when we want to remove the tail, it is not efficient. Okay, so when we want to remove this one, it is not easy, because you want to check, well, you want to update the tail to the point to the previous node. So we want to know which node is on the tail. After we know that, okay, this is the tail, because the last connection node is null, then if we want to remove it, then it will do the connection to the previous node. So in order to check this one, we need to find out where is the last node before the tail. Then the operation time, at least we can have approximately ON, even though maybe this last node will not be counted, but it will be at least ON, because we want to go from the head until the n minus 1. We can use stack for the linked list. So we can implement a stack with a singly linked list. The top element is stored at the first node of the first list. So for example, this is the top, and then this is the next, this is the next, this is the next, and then this is the last. So if we look at the stack like this one, then yeah, this is the horse, this is the second, this is the last, and then this is the top. So we can use stack for this problem. Okay. The space is ON, but the operation of stack will do O1. Okay. When we remove or when we insert, it will be one time. But we still keep the connection between one node and another node. This is the code linked list stack in Python. So this is the link stack, and then you have node, you know the element and the next. So when you construct the initial node, you will construct the element, what is the element of the node, and what is the next. The next means I want to know what is the next node. When we construct, first the head is known and the size is 0. You want to know the length, how many nodes do we have, and then check whether the linked list stack is empty or not, and then push. Okay, so you already know we have push and pop. Push means we want to add the data into the stack, and then pop, it means we want to remove the data from the stack. If we push, then for the head, we want to put the head, and then the size will be added by 1. Top, we want to check what is the top element of the node of the stack. So if the stack is empty, then we put a raise, and then we want to give back the element, what is the top of the stack. When we call pop, it means I want to remove. First, I would like to check whether it is empty or not. If the stack is empty, then go to the exception. If not, then let's check what is the element of the node, and then the head will be go to the next. If I have the head now, if I remove this one, then the head will go to the next one. The size will be reduced by 1, and then we will return back the answer. We can implement Q for the linked list. If we implement the Q for the linked list, then we will have the front and rear. Okay, last week we learned about the front, how to calculate the front, and how to calculate the rear index. The space used is ON. So if we have 1, 2, 3, 4 nodes, then it means the space will be O4, or according to the number of nodes. And its operation of the QADT will take O1. I know if we do the NQ, DQ. So NQ will give you 1 time, and DQ will give you 1 time. So this is the linked list queue in Python. Link queue. First, again, we use node. So this node is similar with the node in the link stack. So here is the node. So when we do with the linked list, the singly linked list, at least we will describe this node. So this is the node, and we want to see what is the element of the node and what is the next section. The remaining part is similar with the queue. So if you look at this one, the initial state or the constructor, we have the head, we have the tail, and the size. Okay. The head is known, the tail is known, and the size is 0. We want to know the length. So we want to get the size of the queue. We want to check whether the queue is empty or not. And I want to know what is the first element. So I want to know what is the front. The front means, yeah, if it is not empty, let's return the head. If it is empty, let's go to the exception. There are 2 operations, DQ and NQ. For the DQ, we want to check whether it is empty or not. If it is empty, let's go to the exception. If it is not empty, let's get the head and let's get the element. Let's move the next as the head, and then size will be reduced by 1. If it is empty, then let's put the tail equals 0. And then if we want to DQ, if we want to NQ means we want to add a new element. So check what is the new node, and then check if it is empty, then the head will be the newest. Otherwise, let's check the tail. The tail next will be the newest. And then the tail now becomes the newest, and the size will be added by 1. Okay. So this is the step for creating the linked list. So this is the code for the linked list. But before I do with the code, maybe I will go to the next section first. Okay, let me just show you one. Yeah, this is the link stack, the one that I mentioned to you before. So I'm using only 3 elements, 5, 10, and 15. So I want to check the top, and then I want to check what is the size of the stack, and then I want to remove the top element. And then stack, I want to know how many elements that I have now after I pop. And then I pop again, and then I want to check whether it is empty or not. And then let me do the pop. Okay. So in the exam, I may give you something like this one. Okay. So if I give you this code, what will be the result? Okay. Now you can see the result is something like this one. And yeah, of course, you need to know what is the pop, what is the top, what is push, and etc. Yeah, of course, if you want to start with the stack, and then you want to immediately check what is the top of the current stack, of course it is error, because at this moment stack is empty, there is nothing. This is another code for the link queue. Okay, I mentioned to you about the link queue. Again, we have node. This is the constructor of the node. So this is the function that I just explained to you. Okay. So this is the code. So let's say I have the truck 1, truck 2, truck 3. Okay. The truck 1, actually maybe there's a connection with truck 2, and then there is a connection with truck 3. Then after I do the NQ, I can check how many queue do I have. Okay, I have 3. And then after I check, oh, sorry, I changed to, oh, at the first I want to make the with the fruit, but I changed to truck. So if the truck has been removed, then yeah, we go to the truck number 2. And then after I go to truck number 2, then I will go to truck number 3, and so on. So if I have the original queue, then I have 3. If I remove the truck 1, then I will remove the truck 1. And then I will remove the truck 2, and the remaining is truck 3. Then the size will be remaining 1. So the operation only just simple. NQ, DQ. Okay. So if you understand this one, yeah, it means you know what is this operation. The next is about the doubling list. In the doubling list, it is quite similar with the singly list. We call it doubling. What we learned before, it was singly. Singly means single. When we have doubly means double. So double, yeah, a doubly linked list provides a natural implementation of node list ADD. Nodes implement position and store. So the position means we want to know what is the current exact position. And it will save the element, and then it goes to the link, and there are 2 links. So if you see here, this is the element. We call it doubly because we have double. The first is we want to know what is the next. And the second one, we want to know what is the previous. And for this one, yeah, usually the data structure will put additional nodes. We call it trailer nodes and header nodes. So the header nodes, this one, it is to allocate that this is in the first part of the data structure. The trailer node, it means this is the last of the data structure. And then, yeah, this is the node to represent every element. And there will be a position. So this position means it is before this one. And this position, it means after this one. Because we have the link. This is the link to the previous, and this is the link to the next. This is the link to the next, and this is the link to the previous. This is the link to the next, and this is the link to the previous, and so on. The doubly linked list application, you can see from the music player. If you are listening to music, okay, the music has a sequence. So the sequence has next and previous button. So it means the data has been in the sequence, and they know that after one song, it goes to the next song. It goes to the next song. If you want to return back, then it goes to the previous song. It goes to the previous song. Browser, for example, in the Chrome, Internet Explorer, or other kind of web browser, they have cache. Cache means a kind of memory. And whenever you go to one web page, you can do the back and forward, backward and forward. So this kind of implementation, they use the doubly linked list. The undo redo functionality. When you are using Hangul, Microsoft Word, you have this function, undo and redo. So this kind of function, they use the doubly linked list for the efficient function. When you do the insertion, when you insert, let's say I want to insert a new node Q. So the node Q will be inserted between the P and this successor. Then it means the operation will be, we will remove this one, we will remove this one, and then the node P will go to the node Q for the next. And the node Q will put the link to the previous, which is the node P. And then the node Q will connect to this node as the next. And the last one, this one, the node C, element C, after we remove this one, it will go to the previous node, which is the Q. Then we will have a new sequence like this one with the doubly linked list. The same with the removal. If we remove the node, let's say I remove the P, then I will put the D here, and then this one, which is the trailer, or the last node, which is empty. So the last node, which is now C, it will connect to the trailer, and in the trailer, it will connect to the previous node, which is this one. And the connection between the element C and element D will be removed. After we remove, then we will remove this overall node into the garbage. So this is the doubly linked list in Python. Okay, let's have a break. I will continue after the break.